So this is the 2016 Junior Cert Higher Level Paper 1 and we're looking at question number 8. John makes a sequence where each stage is made up of a certain number of x's arranged in a pattern. The first three stages of John's sequence are shown below, and the sequence starts at stage 0. So we have stage 0 here, stage 1 and stage 2. So what we want to do here is we want to look at how this pattern is growing. Well, stage 0 has the 4 x's arranged like this. So if we just look at those 4 in each stage, you can see then how it's growing. From stage 0 to stage 1 we've the addition of 3 x's, and then from stage 1 to stage 2 we've the addition of another 3 x's. One here, one here, one here. So there's 3 x's being added each time as we move from stage to stage with the original 4 yellow x's. So part A says draw the next stage of John's sequence. Well, John's going to have the original 4. 1, 2, 3, 4. And then he's going to have the 2 here, plus another 1, 2 here, plus another 1, and then the 2 up here, plus another 1. So again, just to be clear, we've got this time 3 added on to each end of the original 4. So that's our next stage of the sequence. Part B says using a table, a graph or otherwise write a formula to express n in terms of s, where n is the number of x's in stage s of John's sequence. Okay, so well, n is the number of x's, so n will be equal to, if we just go back and have a look, it'll be the original 4. We can see here for stage 1 we've got 3, for stage 2 we've got 2 sets of 3, for stage 3 we'll have 3 sets of 3. So we can see that n will always be the 4 plus 3 multiplied by whatever stage we're at. So if we write that in short, it's the number n, the number of x's, is equal to the original 4 x's plus 3 multiplied by the stage of the sequence that we're at. So n is equal to 4 plus 3s. Part C says there are exactly 130 x's in stage k of John's sequence. Find the value of k. Okay, so let's write our formula again. N is equal to 4 plus 3s. So we're saying there are exactly 130 x's, so we know n. So 130. And that's going to be equal to, that's stage k of John's sequence, so that's going to be 4 plus 3 times the stage. Well, the stage is k, so it's 4 plus 3k. And we have to find the value of k. So we have an equation now, a simple equation to solve. We bring this 4 over. Across the equal sign it becomes a negative, so we have 126 is equal to 3k. So now we can divide both sides by 3. 3's here cancel. So we have k is equal to 126 divided by 3, which is 42. So that's the value of k. Part D. Jchl is also making a sequence. Write each stage, with each stage made up of a certain number of x's arranged in a pattern. In Jchl's sequence, the relationship between n and s is given by the formula n is equal to 1 plus 2s, where n is the number of x's in the stage S of the sequence, starting at stage 0. So we have to draw one possible example of the first 3 stages of Yoko's sequence in the table below. Okay, well in stage 0, S will be 0. So we're going to have n is equal to 1 plus 2 zeros. So that's just 1. So we're just going to have 1x there. Stage 1, n is going to be equal to 1 plus 2 multiplied by 1. And that's equal to 3. So we could have 3 x's, maybe arranged like this, another one added each side. And stage 2 will be, number of x's will be 1 plus twice 2. So that's equal to 1 plus 4, which is 5. So we'd have the original plus 2 each side. So that's one possible example of the first 3 patterns, first 3 stages. Okay, and finally part 2 says P represents the number of x's in stage Y of Yoko's sequence. Write down the number of x's in stage Y plus 3 of Yoko's sequence. Give your answer in terms of P. Okay, so if we write down the original formula, which is n is equal to 1 plus 2s. So it says P represents the number of x's in stage Y. So P is the number of x's, so replace the n with P. And that's equal to 1 plus twice, replace the s with y because it's stage Y, so 1 plus 2y. So P is equal to 1 plus 2y. Okay, well now it says write down the number of x's in stage Y plus 3. Okay, so if we write the formula again, it's n is equal to 1 plus 2s. So that means n is equal to 1 plus, this time the stage is y plus 3, so it's 1 plus 2 by y plus 3. Make sure the y plus 3 is in brackets. So that gives us n is equal to 1 plus 2y. When we multiply this out, 2 by y is 2y, and 2 by 3 is 6. So the number of x's is equal to 1 plus 2y plus 6, but we're meant to write our answer in terms of P. And we know that P is 1 plus 2y. So if we come over here, we can see that this 1 plus 2y here, that's actually just P. So n, the number of x's in the stage y plus 3, is equal to P plus 6. So that's our answer. N is equal to P plus 6. And that's the end of question number 8.